Hello guys, welcome to Talks Riders and the fifth video of Introduction to Applied Numerical Computing series. In this episode, we want to have a look at the SciPy, Scientific Computing Library in Python. So let's dive into it. So SciPy, this notebook. You can find a link to this repository in the description of this video. SciPy is a very diverse, a very big library for scientific computing for different domains. You can see some of them here, which is actually also the different titles of this notebook, but it's much more. Here is a very, very short and fast, let's say, introduction to that. But if you want to use it in practical applications, and this is actually what we want to do also in this course generally, especially when we go for finite element method, we will use it. If you want to use it, you should go to the documentations and read it carefully and also play with some of the examples. But yeah, generally you will see that it's quite easy to use. So it has functions for integrations, numerical integrations, for optimization, for interpolation, for Fourier transforms or different transfers, for signal processing, linear algebra. This is very important for solving linear system of equations, and also statistics and file I/O, similar to NumPy. Sorry. So let's go for that, and not wasting time on this general introduction. So import everything from SciPy, and SciPy has different sub packages, or let's say namespaces, although in Python no one says namespace, but yeah, this is actually the same concept as namespace in other languages. We import them all, and then this notebook starts with special functions, and for special functions they have really good applications in machine learning. For machine learning libraries, they take advantage of this, and in this case is, for example, it is the Bessel function, sort of function that tells you the propagation, cylindrical propagation of waves. And here you have access to those kind of special functions. If you, instead of implementing them yourself, SciPy provides proper interfaces to these functions. So this example is for plotting the Bessel function for various arguments, and you can see that yeah, they are like this. We will cover matplotlib in the next video, but yeah, this is actually how it works. And for integration here, it means numerical integration. And this numerical computing is what this course is all about. I don't want to spoil it, but generally when we say numerical or numerical integration, we mean that something like an integral cannot be solved analytically. So you know that, for example, the value for x squared, the integral of x squared is, for example, x cubed divided by 3. But for more complex functions, it becomes very difficult to compute the integral. And this is where numerical integration comes into play. And it works based on very simple principles for computing the area of area below the curves, but under the curves, I mean. But it's sometimes not very pleasant to implement it yourself. So these kind of libraries like SciPy provides proper interfaces for it. And it's very easy to work with them, actually. You define a function, and then you define the upper and lower bounds. And that's it. And SciPy computes the integral for you using those kind of techniques. And there are different schemes that you can use. I don't want to go through that, but yeah, you can also use, for example, more complex shapes of functions, like in this case a Bessel function, an upper and lower bounds, and you compute the integral. So that's quite easy. And you can see also, you can use also lambda expressions, so the integration of xp minus x squared, and this is actually the square root of pi, the analytical solution. We already know that, and then it means that we can compare the values, the output of the analytical solution to the output of the numerical solution. And for ordinary differential equations, ODEs, you know, we will have lots of discussion on numerical computing of ODEs, but this is not necessarily for numerical computing. So SciPy provides some methods for easier calculation of the solution of the ordinary differential equations. But I don't want to go to this. I don't want to go through the details of this because, yeah, as I said, we will have dedicated sections for that in the future when we want to discuss finite difference method. But you may have a look at this. To see that how easy it is to use these kind of libraries to solve ordinary differential equations, although there are some difficulties if the equations become complex. But yeah, you can see that at least in the complex in this form is quite easy to handle. So this is actually for a sort of pendulum, a compound pendulum that has two components, so a bit more complex than a single pendulum, and the equations are like this, and you can see that how to define the right side and the right hand side and the left hand side of the equations and the initial conditions. Yeah, we will discuss about this, that why do you need an initial condition for these kind of ODEs, and then solving the equation. So SciPy can easily handle this kind of ODEs, and then plotting the results. As I said, I don't want to go to the details, and this is actually plotting the actual pendulum. And also another example for a harmonic oscillator and a more complex equation actually, because this is in a second order derivative, and then solving and coupling these two equations together. You can see that it's quite easy and handy to use these functions ODEInt to solve ordinary differential equations. But yeah, also for Fourier transform, you know what that is. It is a sort of method for in signal processing to obtain the principal components, the principal frequencies of a signal. And SciPy provides very good interfaces for this kind of stuff in signal processing. So this is actually the interface you can see, FFT, and this is actually SciPy, the FFT, you know. And where you can see that, yeah, you can combine SciPy and NumPy. This is actually, SciPy is built on a foundation of NumPy. So everything, most of the data structure, let's say, are NumPy arrays. So you can see that you can use the same skills that you obtain from NumPy video, or generally you have from NumPy, for manipulating SciPy objects. And for linear algebra, this is very, very important for us in this course, because in the end of every numerical computing, numerical solution to partial differential equations or ordinary differential equations, we will discuss later, you will end up with something like this, a linear system of equations. So ax equals b, and then you want to obtain x. And sometimes a and b have a shape of millions of rows or columns. So it becomes quite important to have different techniques to solve these equations. This is a really simple one, but it has also good performance, so you can use it for also quite big ones, quite big arrays and matrices. And yeah, it's actually sort of, you know how it is solved here. So it's a sort of inverse operations. That's why you cannot use it for very high ones. And also you can use it for matrix operations. Then it's just B is split into different columns and then are passed to AX equals B. And eigenvalues for eigenvectors for some specific applications. We don't want to use these concepts in this course, but yeah, they are quite important for lots of engineering disciplines to get the principal components of vectors or matrices. So SciPy has quite nice interfaces for this kind of stuff. And for matrix operations, this is very similar to NumPy. So if you know NumPy, you can use NumPy for this instead of SciPy. And for sparse matrices, as the name implies, it means that, yeah, this is also quite handy, but sometimes, you know, these libraries handle this behind the scenes. So you are not usually involved in this kind of stuff, but in the end of numerical simulations, most of the times you end up with, you know, a large system that includes so many elements, but most of them are zero. And for example, you have some values on the diagonal of the matrix, and then some other elements around the diagonal line. But everywhere else is 0. And if you want to store it in the computer memory or storage on disk, then you lose lots of space for nothing. And as a result, there are lots of techniques. You can see some of them, so-called, here, coordinate form, list of list, compressed, sparse column or row, or others, to store this matrix for you in a way that you can use it, restore it, or more important, do operations with them without really restoring them. So imagine that you want to solve AX equals B, but A and B are sparse matrices or vectors. And this is actually the namespace or the sub-package for doing such operations. And I don't want to go through the details of this because, as I said, we do not engage in this directly in this course, but maybe in the future we will. I'm not sure. And optimization. Optimization is also an important subclass of, works in computational engineering, computational sciences. But SciPy provides basic interfaces for that, yet very powerful. For simple programs, problems, you can easily employ it, and it gives you, it doesn't disappoint you, let's say. And for example, for finding global, in this case, it's local minima. So you have 2 local minima here, one here and one here, and you pass the function to optimize fmin function, and you specify the starting point. So you start from -2 and you end up with this. You can see that you end up with this local minima here. Sorry, that was the function value. So this is actually the local minima. It's actually somewhere here, and you start with 0.5 somewhere here, and then you end up here. So it's sort of saying that the initial point, the starting point, is very important in most of the optimization works. But I don't want to go for talking about optimization in this video. So this is actually the interface that it provides. SciPy provides for doing optimization problems. And then for finding solution to a function, this can be done using numerical methods as well. But in this case, SciPy provides fsolve. You can solve equations. You can see here that you can say that okay, solve this, and then tell me the root of this, the root of the function actually. Interpolation, it means that you have a limited set of points. You can see it here, and then you want to interpolate among them. And this is very important in some applications. We don't want to work with this in this course, but generally that's quite easy. You can say that interpolate in 1D with this, these values, and you can it gives you the interpolated curve, and you can use matplotlib to plot it. And for statistics, I think this is the last but definitely not least things that SciPy provides. For statistics, it provides similar to NumPy. It provides functions like the mean or standard deviation, the variance, this kind of stuff, and also for generating normalized and also distributed normal distributions, or probability distribution, this kind of stuff. It provides functions. So to make it comprehensive, to make the library comprehensive, so you don't really need to go to NumPy to use those features from NumPy if you want to work with SciPy. But still you need some NumPy knowledge, some NumPy skills to manipulate objects, SciPy objects, let's say. And that was it. And I told you that SciPy is very diverse library, diverse package, and there are so many things that you can read and enjoy. I think it was SciPy cookbook. This one. You can see that there are so many examples available here for working with SciPy. You can just go through them and see how the examples are solved. For example, this is a case for solving a differential equations, the way that they define the problem and the way that they solve it. And these are really good starting points if you want to solve similar problems. You don't need to start from scratch, and then you can really learn lots of stuff for scientific computing and also scientific programming in Python using this kind of websites for cookbooks for SciPy. This is a quite famous one, and also SciPy lectures, but I think that's the same. They have converted SciPy lectures to this, if I'm not wrong. But yeah, this is actually what I wanted to discuss about SciPy. So make sure to check it out, and then see you in next videos. Bye.